Good morning, everyone, and welcome to today's webinar by Federated Wireless. We have Michael Ahrens and Steele Bennett on the line with us today. They prepared a detailed overview of the services they have put together to make your CBRS deployments a breeze. Services we're covering today include what POW means to you, how they can assist with GAA, ESC making all the difference in SaaS, and many topics that can help you with a successful CBRS deployment. Please submit any questions that may come up in the question box, and we will cover them at the end of the presentation. To start it off, I would like to hand it over to Michael Ahrens. Michael, the floor is yours.
Thank you very much. I appreciate it, and thanks to everyone who have joined in to this webinar. So we're going to definitely talk about the agenda that we've got here on the slide, plus another topic or two that is really focused on making CBRS deployments relatively straightforward, and quite honestly, they should all be relatively straightforward. So today we're going to cover the following topics, right? And in fact, we're going to be talking about some of the things that you want to keep in mind before doing any type of a deployment, like immediately before. Then we'll talk a little bit about the process of migration over from a pure SaaS, just so that we do this all the time, and just having everybody's expectations in the ecosystem all set to the same thing makes everybody happier when the process is or before the process is underway. We'll talk a little bit about POW. Then I'll touch on our ESC network, and then if there's time, I'll talk about some of our recent feature improvements in the SaaS that we've made over the last few months. So, and then we'll take whatever questions we've got. So I will start with deployment preliminaries. And what do I mean by this? Usually when customers turn up CBRS, they'll either do this through a domain proxy, or depending on the radio manufacturer, maybe configuration of individual radios from specific places. And in order to make sure that the process goes smoothly, right? Because when you deploy something through a domain proxy, if a domain proxy doesn't get a heartbeat response back from the SaaS, for example, it might tell you that there's something wrong at the CBRS level, when really what's wrong is there's a network link down, and the domain proxy doesn't know anything about network links. It knows about CBRS and the protocol that goes between the domain proxy and the SaaS. And when that doesn't work, everything looks like a SaaS failure, and it's not always that way. So what I recommend is that network operators take literally 5 minutes before they're about to go and activate service on a SaaS and run through a few of these steps, right? And these steps are based on the fact that only a few operations really take place between your domain proxy or your CBSD and the SaaS, because the SaaS runs as a cloud service, so it's on the public internet, it's in the cloud, and the only things that happen in order to get from your domain proxy to the SaaS is that the domain proxy has to do a DNS lookup to resolve the IP address of the SaaS, which is, that from an internet perspective, that's hardly rocket science. Then the next thing that happens is once the IP address is resolved, you want to make sure that the IP address is actually responsive. Then you want to make sure that you can reach the SAS and set up a TLS session. So once you've got the IP address, then there's got to be a bidirectionally encrypted session between the domain proxy or CBSD and the SAS. And then certificates have to go back and forth. And then that's it. Then messages should flow. So in reality, it's really only the slightest bit more complex than going to your favorite website, getting from your domain proxy or your CBSD to the SAS. So what we recommend is that before doing anything, you verify that you can reach your DNS server or a DNS server out in the public internet, and you want to conduct these little tests from the same subnet as where your domain proxy is. And if there are any questions on this, feel free to put them in the chat window and I'll address them. But you want to just do a simple ping of a DNS server or the DNS server that you're reaching on the way out, or even if it's just reaching 8888, which is Google's DNS service. If you can do that, then you know the traffic's getting out to the internet and back from you. So there's no firewall stopping anything from leaving your premises, at least not ping to the internet, right? So that's one very simple thing you can do. Then you can also do an NS lookup or a dig to just validate that you get the right resolution for the Federated Wireless SAS. That's a single command. And then there are some steps that you can take using a simple web browser that will validate that TLS traffic is passing and that you can actually, or I'm sorry, that you can receive a TLS certificate from the SAS. And once you get that, then you can be reasonably sure that your SAS connection between, or your connection between your domain proxy or CBSD and the SAS will go smoothly. These steps are pretty straightforward to follow, and there's a short video on them. If you're a Federated Wireless customer, you would have access to this on the My Federated website. Certainly ISP Supplies would have the ability to track this information down. And it's a short 5-minute video that shows you how to actually take these steps one by one. And once you go through them, CBRS, at least starting off your CBRS experience should be a snap. The other thing I wanted to talk about as far as deployment goes is the process of migrating from one of our peer SASs to Federated. And the process is, you can, if you were to just think about it, right? So, let's just pick a particular day to migrate, right? So let's say we choose to migrate on a Tuesday, right? So before Tuesday, you would pick the CBSDs that you want to migrate. And then on Tuesday, you would think that you could just relinquish your grants on the peer SAS, deregister, register on the Federated Wireless SAS, and then get the grants for the same channels as you had before. And if you thought that was the approach you could take, you would be wrong because of CPAS. And I'm assuming that everybody knows what CPAS is, but in case you don't, CPAS it stands for Coordinated Procedures Among SASs. And every night at we'll call it 7 a.m. UTC, which right now translates to 3 a.m. Eastern time, midnight Pacific. For a period of 3 hours, all of the SASs share their data about existing grants and locations of equipment and things like that. And if any grants get relinquished during the day, other SaaS operators won't know about them until after this process, and vice versa, right? If you deregister on a peer SaaS, Federated won't know about it until after the subsequent CPAS. So planning a migration from one SaaS to the other has to take place across a CPAS. So prior to migration, you would select the CBSDs that you want to migrate. And there are some things to consider there too, but let's just assume we're doing everything in one flash cut. Immediately before CPAS on Tuesday night into Wednesday morning, you would relinquish all of the grants on the peer SaaS and you would deregister from the peer SaaS. Then, so you would want to get this done as close to the beginning of CPAS as possible so you would minimize any disruption to your customers. Then over the CPAS process, Tuesday night into Wednesday morning, all of the relinquished grant, all of the fact that you've relinquished all of those grants have been cleared out. They get propagated to all of the other SaaSes, and Federated will learn that any grants you had on a peer SaaS are gone. And then immediately after CPAS, you would re-register and then request the same grants you had, and you're up and running. And we do this all the time. And if you follow this process, it goes, we've done, 1,000 CBSDs in a matter of 15 to 20 minutes, right? The actual time you spend doing the migration, and it should go smoothly. And then with some features that I'll talk about later on in this presentation, odds are the radios will come up right away and you'll be off and running, ready to transmit. I'll continue with the next item on the agenda, assuming that we take questions at the very end. So we'll talk a little bit about PAL, right? And for most folks now, PAL has been out, most folks are aware, that PAL has been out since the end of April, beginning of May. And operators are using their PAL channels right now. And quite honestly, I'd have to say that, for a change that was this dramatic, it actually went kind of quietly. Yeah, we have a question here or there about PAL, but usually the answer is that things are working the way that they're working because of normal PAL operation. So, so let's talk a little bit about what PAL is, right? PAL is a priority access license. And what that gives you as an operator is it gives you the ability to use a certain 10 megahertz block of spectrum in a particular county exclusively, right? And the SaaS has to protect the area around where the CBSDs are deployed, or where those radio frequencies are being used, has to provide protection to them from other operators trying to use the same frequencies that don't have that PAL. And as you know, the FCC awarded 7 PALs per county in the United States. So basically that gives any single operator up to 4 out of those 7 megahertz, the 7 10 megahertz blocks of spectrum to use in any one county. And you have that right to exclusive use of that channel within certain constraints. And I'll talk a little bit about what those are. And I'm assuming, and that may not be a correct assumption, so maybe I'll just set the stage here. There are 3 tiers of operation in CBRS. There's what's called General Authorized Access, or GAA, which is what folks have had in use up until PAL turned up at the end of April, which basically it's a lightly licensed, quote unquote, or really it's more like unlicensed spectrum. You ask for a spectrum, you get it, you get what you got, and you know, there's really no guarantees about it. You just ask for it and you get it. Then at the next little tier up is the PAL tier, right? Which basically gives that exclusive right to use a 10 megahertz block of spectrum, or really up to 4 10 megahertz blocks of spectrum per county, per any individual user, depending on how the auction results went. The auction for PAL spectrum took place last year, just around this time. And then at the top of the hierarchy are the incumbents. Typically, that's the Navy or satellite Earth station operators. And those users have the right to preempt operation from any of the tiers below it. But we won't focus on incumbent actions right now. We'll just talk about the interaction between PAL and GAA, because the upper layer, the upper tier incumbents, they affect both the same way. So the PAL protection process, this is kind of a holistic slide that describes what goes into PAL protection, right? So the first thing is that there has to be a PAL holder. You had to have participated in auction 105 and been awarded that 10 megahertz license for use of that spectrum in a county in the United States. Then, once that license has been awarded, it's tied to your FCC registration number that you get as an operator. And what we do is, for your user account on the SAS, we kind of create a mapping between the FRN for your organization and your customer information. So if you won auction 105 and have got PALs someplace, we knew those results, and we kind of under the covers created a mapping between how we identify our customers to ourselves and the FRN or FCC registration number associated with that operator. Then from the SAS perspective, right, once we've got valid PAL holders, folks ready to use their licenses, the Federated Wireless SAS, through synchronization with WinForum databases and the FCC licensing database, we're able to validate the status of an operator that claims to hold a PAL, validate that the channel that a CBSD is asking for is on your PAL channel as an operator. So say you're, Michael.com. If Michael.com has a PAL in Westchester County, New York, and Michael.com has a CBSD that registers on its PAL channel in Westchester County, New York, it's going to get PAL protection. If it tries to register on that channel in Ulster County, New York, it doesn't get that protection, but in Westchester County, it does. And then the SAS manages and the PAL and GAA grants subject to a number of constraints that are geographic. So we create these things called PAL protection areas that are a cluster of CBSDs that are deployed in particular county, and you draw a negative 96 dB contour around this cluster of radios, and you've got what's called the PAL protection area. And once you kind of put all of those things together, you then have, the PAL holder is then protected against use of that channel. So as Michael.com, if I was using between 3550 and 3560 in Westchester County, New York, somebody else's CBSD would not be able to use 3550 to 3560 in Westchester County, New York, or within certain spots of Westchester County, New York, and might be subject to having its power reduced were the radio to try to use that channel in other parts of Westchester County, New York. So what we've done as Federated is we've tried to put as much of this process under the cover so there's minimal operator intervention required to use it. And we rolled PAL out, and it went very quietly and easily. So I won't spend a lot more time on this slide other than to say that really there wasn't a lot that our customers had to do to take advantage of PAL other than to ask for the channel that they won the PAL license, that they won the PAL auction with. So with that in mind, I wanted to just show a few different use cases for how PAL and GAA activities will work out in the field. So what I've got here is a diagram with two different counties here, and we've got one operator. We've got operator X, which has got a cluster of radios in this area here, but there's another operator, operator A, and it's put its device, where it's somewhere in that negative 96 degree contour for operator X, right? That can happen. It happens all the time, right? And operator X also has some other PAL protection areas across these two counties. But the key point here is that operator A has a radio that's stuck in the middle of operator X's PAL protection area. And the SAS will not allow co-channel operation between operator A and operator X if operator A's radio is in this PAL protection area. The grant won't be allowed, and if it exists, it'll get terminated. However, in this situation here, right, you've got similar type of a thing. You've got operator X here, and you can see that operator X has got PALs on two channels. It's got a PAL on 3550 to 3560 and 3560 to 3570. And it's got these channels in two different counties, three PAL protection areas. So there's a cluster of radios here, there's a cluster of radios there, there's a cluster of radios here. Let's say operator A is deploying its CBSDs, but this time, instead of it being deployed here in the PPA, it's deployed somewhere within 40 kilometers of it. This radio here can use the same channel. It can use a channel between 3550 and 3570. However, its EIRP is subject to be reduced because of PAL Protect, because we're protecting operator X, which has got the PAL in this county. If this is a big county and you've got a relatively small PPA, if you have another CBSD that's outside of this 40-kilometer boundary, there's no protection required for PPAs 1 and 2. Right? If you're outside of this radius, then your CBSD should be able to operate just as it had before. No protection required. Couple of interesting things happen, and then that, by the way, is kind of general. That would be the case regardless of you know, where, regardless of the companies that had the PAL and the companies that had the GAA. But these use cases that are coming up here has to do with an operator that it has a deployment that spans a couple of counties. So typically, when you deploy CBSDs, if you were to deploy CBSDs here, right, in this area, your contour might extend across a county boundary. But from a SAS perspective, where the county boundary exists, we actually, that divides this PPA into two parts. So if we weren't watching out for this scenario, we could actually be protecting operator X from itself using its own PAL. So what we do in this instance is we basically regard these two separate PPAs as one PPA. It's the same operator, same channels, the PPAs get merged and it looks like one PPA there. So that way operator X devices are able to operate at their full power on their own channels, and protection is applied for other CBSDs trying to use those channels according to the rules I outlined before. Another use case is that in the Federated Wireless SAS, we have some organizations that are hierarchical. So we certainly have our share of wireless internet service providers, but we also work with some large organizations that are split into multiple parts, and their CBSD deployment is split into administrative chunks that correspond with their geographic alignment. So for example, you know, let's say this is a large carrier, and they've got operations in the West and they've got operations in the East. And you know, this county is what these two counties are where East and West meet. But they all apply to operator X, but they're different from the Federated Wireless SAS perspective. They register with different user IDs, even though they belong to the same operator. The East and the West, they get different user IDs. In that case, since they have a common parent, also we merge these PPAs. So operator X is not protected from itself. So we don't arbitrarily enforce that kind of protection for something that's going to span counties. Another use case, same operator, but they're different channels. So a PPA is an operator, a channel, and a county. So if you've got operator X, same operator here, but you've got this one on 3570 to 3590, and this one on 3550 to 3570, these look like two separate PPAs, right? So, so there would be protection for each of these things individually for their respective channels. So those are kind of a few use cases about how GAA operations might be impacted by PAL operations. There are other considerations as well, but those are the most prominent ones that we see. And handling them, you know, if PAL is confusing to anybody in this respect, it's helpful sometimes to think of a PAL as a a grandfathered wireless protection zone, or a PAL protection area as a grandfathered wireless protection zone. The protection rules are exactly the same. And really, geographically, what all they are contours. It's just that for grandfathered wireless protection zones, those are static. For the towers are the towers. You turn the radio on, those frequencies get protected in those areas, and that's it. But because CBSDs, they can get channels dynamically, they can relinquish channels dynamically, etc. The whole notion of a PAL protection area is dynamic. So even though it's protected the same way as a grandfathered wireless protection zone, it's a dynamic one. So, if you're wondering how to think about PAL and why things are protected that way, it's helpful to think about, well, what if this were a grandfathered wireless operator? What would make sense there? And that's a helpful way to think about that. I'll take a pause here for a moment. I know we probably want to do questions at the end. I'm just doing a time check. And I think I have enough time to go and talk about the ESC network.
Yes,
So
sir. We have plenty of time.
Okay, great. Yeah, so the federated wire, so CBRS requires the use of a sensor network to detect naval activity. Federated Wireless has got its own sensor network that it designed, built, and deployed around the United States, around the coast of the United States. And the purpose of, and since we designed it, we built it, we operate it, we manage it, it's fully under our control. It is a, as with any network, it is a sort of a breathing entity and requires constant maintenance, care, and feeding, right? That's the truth with any network you've got, not just with this one. And what drives that care and feeding? What is it that makes our sensor network unique? And the amount of, because we don't share it with anybody, we have the ability to control it at our pace. And really, as customers, it's at their pace, right? It allows us to be more nimble as far as how our sensor network might impact them, because the presence of the SAS has to protect sensors. Our SAS has to not only protect our sensors, but we have to protect the sensors for peer SASs as well. And, in order to do that, it's a geographic thing, right? So there are things that you can do on a sensor. You can locate it in a different place. You can tweak its azimuth, or you can do all sorts of things like you could with a radio. And that has, those adjustments have an impact on the footprint of the number of radios that might be impacted by incumbent activity, or that might require protection from GA operators. So one of the strategic goals of why we manage our network is to reduce the footprint of radios that might be affected by incumbent activity, right? So if you're in a location, in an unoptimized world, say you had 100 CBSDs off the, that are near the coast of Wilmington, North Carolina. Every time the Navy shows up around Wilmington, North Carolina, you'll bounce all of those 100 devices off, right? Unless you tweak the ESC network so as to minimize the likelihood for CBSDs to interfere with those devices, right? So we try to minimize the impact minimize the footprint for radios that would be impacted by the operation of sensors, because we have to protect them. In addition, because our sensors are located in coastal regions, some of them are more susceptible to natural disasters, hurricane. We've been through a number of storms now. We've been through some ice storms. We've been through some hurricanes. We've learned some valuable lessons about the kind of resiliency you need to fully protect the naval incumbents, right? And we've made a lot of these enhancements to the network in order to make sure that in the event that we get a sensor taken out due to a hurricane, that we don't impact customer service, because we have enough redundancy built into our ESC network design. We can afford to lose a sensor or two in an area and not have to take the whole area down. In addition, we have made some adjustments to generator power. We've made some upgrades to the modems that we use for backhaul, all to improve the stability of access and reduce the likelihood of or duration of impact to customers that would get might have their grants suspended due to incumbent activity. Part of this optimization, most recently, we've rolled out this 2.5 antenna, and we're just about done with this deployment. We're just about wrapping it up. Literally this week or next week, we should be finished rolling out these improved antennas that improve spectrum availability, and it shrinks the amount of space over which we need to protect that sensor. In addition, we've upgraded our power cabinets. So in specific areas, and we're just about done with this too. We're down to our last device in Texas right now. We've gone to those sites in the United States that are most prone to storm activity. So Texas, Gulf Coast, Florida, etc. And we've replaced our power cabinets for something that offers 5-day battery backup, more responsive backhaul switch, and we can operate for 5 days from a power perspective after power is cut to the site. So that should give ample time for a technician to reach a site after a storm and restore any type of service there. But so this is work that's been ongoing since the fall of last year, and we're down to our last device here too. So completion of this is imminent. So a lot of improvements to the ESC network over time, and we're able to do this because we own it, we operate it, we don't have to share it with somebody. We're able to be as responsive as possible to customers who might be impacted by naval activity. And finally, the ESC network is just about fully built in Puerto Rico. So by July, we expect that the full 150 megahertz will be available for operators in Puerto Rico to use. And that's because we wound up putting a number of sensors out around Puerto Rico. So now we can protect that. So that's recent activity, and we're looking forward to be able to provide full spectrum availability in Puerto Rico. So those are some remarks about the ESC network, and I'll just add a couple of comments on some SaaS features. And two of them in particular are same-day grant and the enhanced spectrum inquiry. So if you are not familiar with the process of getting a grant for spectrum, when a CBSD gets a grant, or in the days before, I'll say in the days before the same day grant feature, so put yourself back in January or February of this year, what would happen is to turn up a CBSD, you'd power it up, you'd register it on the SAS, you'd request a grant for spectrum, and you'd get the channel, and then after, your first heartbeat, your grant would then get suspended because you had to wait for CPAS because of where you were located, right? If you're near an incumbent or if you're in a DPA area, you'll wind up having your grant suspended, and you'll have to sit there for, up to 24 hours. But in the spring, earlier in the spring, we introduced the same day grant feature. No real configuration needed to use it. But what the SAS will do is, and in most cases it does, is it will immediately authorize the device based on a simpler calculation of available EIRP in the area. Possibly, most of the time, we can authorize a grant at the EIRP you request. If not, we can grant it at a lower one. I have yet to see a case where a CBSD still needs to wait for CPAS with same day grant. So what this does is this makes operation or makes these migrations very simple in that, after you get your grant, same day grant will kick in right away, and you'll be able to transmit instead of having to wait for a day. So that's a plus. Then another feature that we have is the enhanced spectrum inquiry. And what we're doing is we are returning the EIRP in any spectrum inquiry response. And what that allows the CBSD to do is to pick the best channel. And in some upcoming features, it will leverage the capability of the enhanced spectrum inquiry, just based on the virtue of the order in which the available channels are presented. So when you use these two features together, they have the ability to impact for the better new installations as well as service interruptions. So for a new install, like we talked about before with that whole Tuesday, Wednesday thing, after your overnight and your CPAS completes and you're registering on a new SAS, let's say it's the Federated SAS, right? So you switch from SAS X to Federated. When you do a new when you're doing that switchover, all of the grants that you request could be authorized right away. So that simplifies that process. And then another use case here is when you're operating steady state and the Navy comes along and bounces your devices off of a channel. It used to be that when a CBSD got its grant suspended due to incumbent activity, it would go for another channel, but have to wait for CPAS for that other channel to be cleared for use. But with same day grant, that doesn't happen anymore. You can find another channel and just use it right away. So it helps to mitigate the impact of interruptions as well. So CBRS has been a lot more user-friendly since the spring when we introduced these couple of features. And with that, that clocked in right at about 45 minutes, and I think that covers the agenda plus some. So I'll pause here and I'll take questions from anybody who has them.
Excellent. Thank you very much, Michael, for that in-depth rundown of the services. A few questions did roll in, and we still have some time to cover them. One of them is, if there are PAL license holders around me, do they get all of the GAA spectrum, or will there be channels available for me?
So we'll go, let me pop out of here for a second, and I'll go back here. Actually, this is probably a better picture. Right, so what you're talking about here is a case where, I'm operator X and I've got this county, right? But, my radios are all kind of located relatively close together. So I've got a PPA here and I've got a PPA there, but it's a big county. And if my radio is located outside of this 40-kilometer radius or outside of that 90 neg 96 dB contour or neg 96 dB contour around the PPA, if you're located outside of that 40-kilometer radius, then you can use GAA just as you did.
Hey, Michael, if you're trying to show something, I'm not seeing it. I just wanted to let you know.
Oh, really?
Yep, I'm seeing a general screen that says Federated Wireless CBRS Services Overview Webinar.
How about now?
That's
there
it.
we go. Perfect.
Okay. All right. So starting again. Did my screen just go off again?
Yep,
Yes.
it's back now.
Now it's back. Yep.
Good. Sorry about that. So as I showed here before, so let's say you have this county 1 and it's pretty big. You've got an operator with PALs located in that county, and their radios they're typically clustered together. A few towers nearby. Within 40 kilometers of that PPA, if you've got a CBSD, if you're a different operator and you've got a CBSD outside of this 40-kilometer radius around the PPAs, then you're operating on GAA just like you were today. If you are in the county and you're within 40 kilometers of the other operator's PAL protection area, then you can still use their channel, but it's subject to having power reduction. So how much will it get reduced? It depends on where you are. If you're out here somewhere out on the fringes, you may lose a dB or two. If your CBSD is right here on the edge, you may get knocked down to negative 15. So that would make that impractical. So in which case, in that scenario, then you would just use a different channel. And if your CBSD was located inside this PPA, like it is here, this wouldn't be allowed. But this would be this radio could transmit, and so could that one. So hopefully that answers the question.
Excellent. Thank you very much. Another question here is, how far inland do the DPA reach? If I'm in Dallas, am I impacted?
So the DPAs reach a different distance for wherever they are. So I'm gonna pop out of here for a moment. I'm gonna stop that, so nobody can see my screen now, right? Right.
No, I'm still looking at the slide you were showing before, Michael.
Good. Okay, that's what I want. So so what I'm going to show you is 3550 to 30. Gosh, I'm looking for something, and I will find it, of course, when I'm looking for it. Okay, here it is. All right, very good. So I'm going to put this URL in the chat window. That's here. So if you go to the ntia.gov website, you'll see these KML files here. And if you download this I recommend all of the, this one, the one, these last 5, don't use the one that's deprecated here, but the other ones will show you the DPAs, and you can put them into Google Earth. And if you look at, so these are the DPAs around Puerto Rico, you can see that if you load that KML file into Google Earth, you can get a display that shows you how far inland the DPA extends. So for example, your DPA neighborhood for Cat B in Puerto Rico, it's 200 kilometers, right? So that's bigger than the whole island. But if you were to go, say, around Texas, right? So you had asked about Dallas. I don't think it'll go as far as Dallas, but if you're like up here in East 24, you could go in 368 kilometers from here and possibly be affected. Now, how big is 368 kilometers? I'll see what that is. So from here to there, right? So Dallas is just outside, but you're not far. You're like right around here. You're almost to Dallas, right? So bottom line is that, in that part of Texas, you might be dealing with 368 kilometers. Over here off the coast of South Carolina, the DPA neighborhood might be, it's 416. So that goes further, right? So it depends, but to get the accurate information, I recommend you go to the NTIA website and download the KML files and put them in Google Earth, and then you'll have the answer for any DPA.
Excellent. Thank you for showing us that response. Another question we have here is, what's the difference with your ESC network and any other ESC network?
Well, aside from the fact that we've got Alfredo, who built and deployed it, and the fact that we own it and operate it entirely ourselves, so the equipment is our design, and we work very, very closely with the Navy and the Department of Defense to build and vet the equipment and deploy it ourselves and operate it ourselves. I think that's the key differentiator there, is that because we manage it ourselves, we don't have to coordinate with anybody else to do maintenance on it, right? There are other SaaS operators who share an ESC network, and one operator will, or one of those SaaS operators will be beholden to the other one, and vice versa, right? So that's really the key thing, is the fact that we control it and that we're actually very aggressive about maintaining it, as as I've outlined earlier in the presentation.
Excellent. Thank you. And last question is, can I really use GAA in a very busy area just like San Diego? There are incumbents, PAL license holders. How can I get any spectrum?
So San Diego, I will admit, it's a tough area, right? Just because there is naval incumbency there, as you know, it is congested, but there are plenty of operators there who are getting grants, who are using spectrum, and it really does become an exercise in what I would call RF planning, right? You would need to look carefully at the area. You'd have to figure out what the right azimuths are, what your right down tilt would be, based on whatever you would know about the area. Federated does offer professional services that can help you figure out, where you can actually get spectrum. Now, I will say that coming in the towards the end of June, we're going to be introducing our initial coexistence features. And that will provide a better view of what kind of EIRP is being used in the area, what channels are most heavily used in the area, so you can use that information to your advantage when doing some of this planning. So San Diego, I will admit, it's a tough case, right? There are some places that are in the middle of Wyoming, CBRS, no problem. You turn it up, you don't even have to think about it. But in San Diego, yeah, you do have to give it some planning, and we're looking to give better tools on the SAS GUI to help with that. And where those may fall short, and hopefully they won't, but we have a very, very accomplished spectrum architect on our team, and our whole chief technology officer organization has got planning tools and can work with you, on a fee for service basis to do RF planning.
Wonderful. Thank you very much, Michael. And that concludes all of the questions for this webinar presentation. Thank you very much, gentlemen, for all the information and putting together these slides. We will be posting a recording of this webinar to our YouTube page at youtube.com/ISP Supplies, as well as on our Facebook page at facebook.com/ISP Supplies. So please make sure to subscribe and follow us. And thank you, everyone who took the time to attend today. If anyone has any questions or would like to look into the services that Federated Wireless has to offer, please call us at 855-WISP-PRO or email us at sales@ispsupplies.com for assistance. So once again, thank you, everyone. Have a great rest of your week, and God bless.
Have a good day, everybody. Thank you.